So 7 grams, dude. That is a huge. If you take the exercising one, that is insane. Like how much glucose you're gonna be able to clear.
Let's see. Yeah, for the exercising one, 22.8 milligrams, like 1.4 grams per hour per kilo. Yeah,
that's insane.
So, like, even for these guys who supposedly have like 30 something kilos of muscle, right? You're talking 40 or 50 grams of glucose an hour during exercise. And then if you actually make it a reasonably muscled human being, that's going to be even more. Yeah. That's about right, though, actually. If you think of during exercise, once you go above 40 to 50 grams of carbohydrate per hour, you start to see problems like the gut won't take up much more. So maybe actually gut uptake during exercise and muscle uptake during exercise are fairly well matched, which would make sense, wouldn't it?
Speaking of which, for this episode of Bro Research Radio with Dr. Tommy Wood, I've prepared adequately by not reading any of the citations. And I have instead eaten 140 grams of carbohydrates. And we're going to see what my blood glucose is. I did about 25 sets of some hard work, so we're going to see how diabetic I am.
How long ago?
About an hour, maybe a little bit. Oh, 107. Take that, motherfuckers. It's pretty good.
It's all right.
Yeah, 140 grams of glucose. So a lot of people don't really understand like what that means. And so these numbers don't mean a lot to them, but diabetes is after 75 grams, you'd be at 140, and like 126 fasting. And so what we've seen in a lot of muscle bound individuals is just an insane ability to dispose of glucose. And we're going to jump into a couple research papers today. The reason I wanted to have Tommy on the show is because this paper just came out that was, we don't generally have exercise trials, unfortunately, don't generally have a lot of money. And so this trial had an intravenous glucose tolerance test, which has its negatives, but it is, that's like $1,000 per person type of test. And so it was a really interesting study design. I'll just share my screen and we're going to jam on this and then we'll that's that Ronnie paper. And so they had these people come in and it was a rubber exercise. It wasn't resistance training. And they had them essentially exercise off a 20% deficit or a 40% deficit. And then they looked at an IVGTT, an intravenous glucose tolerance test the next day. And this study had a lot. They used a metabolic cart to figure out RMR. And then the finding is pretty interesting, and you can kind of extrapolate more on this, is they didn't find much with the dietary restriction. So essentially they were testing what happens when you exercise off 20 or 40% of a deficit, and then compared to what happens when you eat at a 20 to 40% deficit. And kind of this in the functional medicine sphere, one of the big things we have is like, okay, if you're in a deficit, you're probably going to increase your metabolic health. But acutely, that doesn't necessarily look to be the case. It's more probably changing body composition over time. And so they had this insulin pop here, which is, and you can help me with, because this is your area of expertise. They're giving them boluses of insulin right here, right?
No, this is just an intravenous glucose tolerance test. So that's the insulin that they're producing in response to the glucose. That's
what I thought too. But look at, so a glucose bolus of 11.4 grams, I think this is for height. And then that's why I don't know how to extrapolate this.
Yeah, you're right. So the first bump you see, that's their endogenous one. And the second bump is with the exogenous insulin, right? So you see that first bump.
Yeah, so they're already at 150, and it's also like good to say, like, these people, they're quote unquote healthy, but they're not. They're already pretty metabolically deranged.
Yeah. So and this is the point that it's the reason why they did the intravenous one, and they make the point in the discussion that the oral glucose tolerance test would potentially be more like real life, because then you get things like GIP, GLP-1, you get the incretins from the gut involved, which stimulate insulin production or modulate insulin production. But then they couldn't look, because they wanted to do 2 tests. They wanted to in one go. So that's looking at the endogenous response to insulin, and then like if you shove a lot of insulin into the system, like how does the body respond to that? So they did both at the same time, which is why they did it intravenously. That's right.
And really the only significant finding here was this acute insulin response went down with exercise and also with diet, but it went down with diet because they just weren't eating as much carbohydrates, which you would expect. And then this is kind of their other main finding was that the SI, or the effectiveness of glucose, went up, which is glucose sensitivity.
But only in exercise.
Only in exercise, which is big.
But in the diet one, particularly at 40% deficit, there's less of a disposal index and less of an efficiency of glucose stimulated glucose uptake. So that's kind of, you're basically reducing like the relative amount of glucose that's taken up into muscles. And like, you know that if you're in a chronic caloric deficit, you do have some degrees of peripheral insulin resistance to try and spare glucose for the brain particularly. So I think that's what you're starting to see there, but you don't get that when it's induced by exercise, at least not acutely.
That was my big question, because it seems like if you go vegan, you're going to have this down regulation of your ability to digest protein. And so the same thing seems to be happening when you back off on calories, right? You have this down regulation of your insulin secretion, and then you also are starting to spare glucose for your brain and other organs. And so what I've seen anecdotally is some people that go keto, they kind of mess up their ability to deal with carbohydrates. And I think that would come back, just like if you're vegan, your ability to digest meat protein comes back, but you can't just eat a steak and think everything's going to be okay right away. Would you agree?
There's a part, yeah. So this part, so this is that it kind of comes up with that other review paper that you have, and they do talk a bit about this, particularly in relation to glycogen levels and appetite. The ability to spare muscle glycogen and the use of muscle glycogen seems to improve after a period of keto adaptation. So I think you will see an acute deficit, but some of that may come back. And I think it's also going to be related to the intensity of the exercise that you're doing. So if you're thinking about the amount of carbohydrate that you're shuttling through glycolysis and then into the mitochondria, acutely on a ketogenic diet, or even you might see a down regulation of pyruvate dehydrogenase, so less shuttling of pyruvate into the mitochondria from like glucose and glycolysis. But PDH is upregulated by intense exercise. So I think if you're worried about your metabolic flexibility on a ketogenic diet, I think you can offset some of that by making sure you're actually doing high intensity exercise. But when you're thinking about all of this from an appetite regulation standpoint, which is that other paper, the one that you've got up now, I think that they're worried that if you're on a low carbohydrate diet, you have lower leptin levels, and if you have lower leptin levels, you might, lower leptin is going to make you hungrier, essentially, right? You're going to try and regain caloric balance. And some of that is tied into your ability to use fat versus carbohydrate during exercise. So if you are a carbohydrate dominant athlete, i.e. you do not have true metabolic flexibility, the more likely it seems you are to eat all of the Oreos after you've worked out because you're super hungry afterwards. But if you are more metabolically flexible, you're able to use more fat during exercise, you actually have less of that. So people who are better trained, have more metabolic flexibility, are better able to regulate their appetite.
And they're glycogen sparing.
Yes. Yeah, exactly. So all of that comes from training, but if you go, in terms of your dietary extremes, and remove carbohydrates from the diet, you can gain some of that back. It just requires an adaptation period. So it's different ways to skin a similar cat.
Yeah, and you kind of see that in a lot of the low carb. They're doing a lot of carbohydrate bunching. Like even if they're low carb outside, they're trying to train. They're training low, competing high, like stuff like that. They're not just all the time keto. maybe if you're an ultra, but then you're never even worried about carbohydrate metabolism really anyways, because you're staying at such a low, you're at 60% or whatever, you're under that threshold where you would even use carbohydrates.
Well, I mean, the best keto endurance athletes, when they're doing high volume training, they eat carbohydrates and still stay in ketosis, right? They can eat several hundred grams of carbohydrates and stay in ketosis. That's
around training, or
around training. Even throughout the day. Like if they're doing an enduro bike race or multi-day ultra marathon, if they have that carbohydrate either during or around the actual bout of exercise, the next morning they're like bang back into ketosis. So you can still, and that's probably because all of that glucose is going straight to the muscles, right? But one interesting thing about this paper we were talking about with the glucose uptake, but with the different caloric deficits, is that, and this is where I get really annoyed by the way that people display their data in papers. So you're trying to understand who these people are, right? Like what are they like? And if you look at, so what they give you in table 1 is like your
basic facts, right? Table two is their basic demographics.
Yeah, so like basic demographics. Actually, most of it's listed in the text.
Yeah, so it's like 18 to 30 BMI. It's like
the BMI range is 18 to 30, but on average it's 20.9 and 22.5 in the exercise and diet groups. And then I'm like, and it's roughly, there's men and women. And so then you're like, well, what does that mean? So they give us the BMI and they give us the percent body fat. So these guys are 20 to 22.5 BMI on average and over 30% body fat. So like, but they don't tell us how much they weigh, and they don't tell us how tall they are. So I went and I was like, so the average Korean, so I went and looked this up. Average Korean female is 5'4", male is 5'9". So I like guesstimate, like on average, these people are like 5'7", right? And already we're working in averages, which means that it's telling you nothing. But based on that calculation, the FFMIs of these guys are somewhere between 15 and 16.5 on average, right? That's like almost negative muscle mass.
Yeah, well, if they're females, that's still. But we don't terrible. Know. Like their breakdown was 10 to 3, right? Their breakdown was 10. It was 10. There's more 22 women and 10 men.
Yeah.
Yeah. So
it's like a third to 2/3.
Yeah. That always, like, I understand that we want to have both sexes in, but that just makes data presentation so convoluted when you have males and females mixed together and you don't present the data separated.
Well, all you need to do is just, you have 22 people. You can give us all the data for each person, right?
Yeah.
Put it in a supplement. And then actually then you and I can go, okay, let's find somebody, either a male or female, who has the body composition of somebody who's the kind of person that we're used to dealing with, that we're interested in. And then we can look at their data, right? Whereas with this, it's just such a mixed bag of metabolic health, body composition that, yeah, it's interesting, but it's just really difficult to know how to.
Did you just say that you don't care about 5'4" Korean women? Is that what you just said? Did you just say that on the internet?
That's really not what I said. I'm a big fan. No, I can't say that either.
No, can't say that either. You just got to be quiet. This is the age we live in. No, so I think you bring up a big point. Is these subjects are incredibly under-muscled. We know that 91% of Americans are over fat, and then if you put in like metabolically healthy, maybe there's like 1% of people who are metabolically healthy and have enough muscle mass for our recommendations. And so we're extrapolating out a ton because we don't have the data in the population that we primarily serve.
That's a better way of putting it.
Yes. My wife has been coaching me up on how to talk in a politically correct manner, because otherwise it would be terrible. And so you and I were bantering back and forth via text messages, because what we see in the research is they always compare resistance training to, say, aerobic training for diabetes regulation, in diabetics or people who are already metabolically dysregulated. And what they see is there's no difference acutely And like, so this is really interesting to me. So you have this unhealthy population, and if you get them exercising, they get better metabolically. But, and for weight loss, this is why exercise is kind of you have to do it, because otherwise you're going to lose muscle mass and you're not probably going to get that same metabolic benefit. But if we think about our population with the accruement of muscle mass, you essentially should be able to dispose of more and more and more glucose. And why this is interesting is those like 8-week or 10-week studies in metabolically deranged individuals, you will see muscle mass gain from just aerobic exercise in those first 10 to 12 weeks. So are you really comparing apples to apples in that sense? Or is it what happens when, you know, someone trains for 3 years and they put on, you know, 3 years, you might be able to put on legit 10 kilos of muscle. A female may be able to put on 5 to 8 kilos of muscle in 2 to 3 years. And we did the math, and that is not exercising. That's like 4 grams an hour of more glucose that you're essentially going to be able to get rid of. And exercising, what was it? That's like 20, almost 14, 15 grams of glucose that you could potentially get rid of by adding muscle mass. Mm-hmm. And if you think about, and so we talked about this, my glucose level was 107 milligrams per deciliter. The difference, you have about 5 liters of blood flowing around in your veins and arteries. And so the difference between diabetes and so an 85, so being quote unquote healthy, and then diabetes is 2 grams. And so if someone has the ability to dispose of, you know, 15 extra grams of glucose in 2 hours, that is an insane amount in terms of, and that's the thing that we kind of want to look at, is when you essentially analyze people who are muscle bound, you kind of get to flip the switch and see how much glucose they can dispose of, instead of seeing, oh, how fragile are they?
There's a discussion of this Korean paper where they talk about how you can very quickly lose the insulin sensitivity by being sedentary. So there's definitely an effect of, not only do you need, we talked a little bit about this on the last episode, I think, is like, not only do you need a good amount of muscle mass, but you actually need to make sure that you continue to use that, right? That you're not, you know, you can't just be super stacked and lay around all day. And otherwise you'll lose that insulin sensitivity that muscle mass should otherwise afford you.
And that's another thing, like anecdotally, people, for some reason always ask other people, like they care like what I do. And so I'm sure people care about like what you do as an individual. We, as scientists, we don't really care about that stuff. We find it interesting for like driving hypothesis, but like I'm already at 9,000 steps a day. I woke up at 4 a.m. to like carry a baby around. So like I'm probably not only did I train, but I'm moving around a lot. And I'm just pretty hyper in general, which is kind of annoying for a lot of people. But if you're at a desk, like I think if you don't have a lot of muscle and you sit at a desk all day and you ate 140 grams of glucose, like that's not going to go well. And then honestly, that's like probably a couple cupcakes, which is scary to me. Like, so if you're at an office and you just pounded a couple cupcakes, you could be in, you know, just blowing glucose out of your kidneys.
Yeah, literally. You would go over 180 when you then start milligrams per deciliter. You then start to lose the ability to reuptake all of it. That's just like, it's the donut. It's the donut that your coworker brought in. I mean, I do partake in the donuts that people bring in, but then I go and do squats afterwards, so I justify it that way.
Well, I don't think that you have, like, the point is I don't worry about carbohydrates. Like this, right. It's never a worry for me. Like if someone wants to like eat an entire peanut butter pie, I'll be like, yeah, let's take our glucose. Let's see what happens. And it's not even good. Like anecdotally for me, there could not be a worse time to test my blood glucose. I've been trying to eat at a hypercaloric setting for like 3 months straight. I'm eating 4 RX bars a day, 2 bags of chips. Like, it's terrifying. And I still can't gain weight. So maybe I got to stop being so hyper.
Yeah, you got to stop those 9,000 steps a day.
No, I'm at 13, 9,000 by noon. Yeah, for sure. So but then part of me is like, okay, am I just going to gain fat then? Maybe, but that could be advantageous. I don't even really, because I'm not gaining weight consistently. I might not even be in a caloric excess, which is I'm probably necessary for me to put on muscle.
Yeah,
which is not the point of this podcast.
I think you need more peanut butter pies.
That is what it is. I'm in. Peanut butter is quite expensive here. I probably need to just start facing bananas, just like 10 bananas at a time. See how many bananas I can put in a smoothie. The main finding from this Korean paper was that they found the more exercise you did, the more insulin sensitive you are, the better you were able to use insulin to dispose of glucose. But they did not see the same thing with diet. And if you look at all the research, you probably, to me, it's pretty clear that you don't just want to diet without exercise. Like that's a recipe for disaster. If you're getting 3,000 steps and you're trying to diet and you're an office worker without exercise, I think you're just going to lose muscle. And then you're going to, with the collateral fattening effect where your body's going to eat to try to bring back the amount of muscle that you had, it's just going to be bad news bears over the long term. And so, but this other paper that's kind of related to this, but is really weird. I think for a lot of people, this idea that glycogen could be a regulator of appetite control. And then I found this kind of fact fascinating, is that, and I've definitely seen this anecdotally in people who are pretty well muscled, and even just people who exercise a lot, is they're fasting. They need to eat often. Their fasting appetite goes up. And their explanation for this is your liver glycogen utilization rate is your liver glycogen essentially doesn't go up from exercising, but your muscle glycogen does. And so you're repleting that. And so you're going to use your liver glycogen faster. Is there anything else? Is there anything you found super interesting? This is more of a hypothesis type paper, or almost like a narrative review. Anything you found super interesting in this paper?
Yeah, the main thing was what I was talking about earlier, in that, particularly if you're trying to use exercise as part of a fat loss strategy, then doing whatever you can to become metabolically flexible is really important. You want to be able to use more fat during exercise so that you spare glycogen stores relatively. You have less reliance on gluconeogenesis during exercise because you're able to use fat stores. And then those are the people who seem to not super compensate for the calories burned by exercise after exercise. I definitely know. So from the people that I've worked with, and also myself, I know that I am actually is where I eat a load of food. So if I put myself into a caloric excess, I find it really hard to keep that going. Right, I'm just not hungry anymore, and that's not the case for people who are in a caloric excess, but are sedentary. That's also mentioned in that paper, right? That again, they are less well able to regulate appetite. But if I am using carbohydrates as the main chunk of my caloric excess, it's easier for me to maintain that, right? I get hungrier. So I've definitely seen that in people who come and they're trying to gain weight or gain muscle mass particularly, or just gain weight in general, and who are eating a relatively low carb diet. If you add carbohydrates into the diet, they seem to be hungrier. They're definitely, like in the mornings, that they're definitely hungrier when they've been fasted for a period of time. So I think that's probably similar to what you were saying. I've certainly noticed that. That's a strategy. If you're trying to gain weight, and you're struggling on a lower carbohydrate diet, and it can be done. Again, we talked about this last time, right? But if you're struggling to get those calories in, then adding in carbohydrates can seem to increase appetite. I think, you spent a lot of time trying to figure out where glucose is going and coming from, right? And I think, at least based on the data that exists, there's a definite rationale for saying that, adding a kilo of muscle will significantly increase the amount of glucose that you're able to dispose of. And that's, that's the whole game for a lot of, metabolic health and long-term health, right? So,
and that's what I don't think we're seeing in a lot of these, these 16-week or even 6-month trials. Like if I think of the order of operations in which we research this, right? It would be first cross-sectionally, let's compare people with an FMI of 24 to males. You could use males or females. It didn't matter, but females with an FMI of 21 or 22 compared to females with an FMI of 15. Same age, same things like that. You could even, honestly, like from a study design perspective, you would probably want them to be like the same, almost like the same body fat percentage. So like you'd want them to like, so an FMI of 25 and 10% body fat versus an FMI of 18 and 10% body fat. And so you'd compare those two subjects, and then you'd look at, say, an OGTT, and you'd look at their ability to clear glucose. And that would be really interesting. So if we were going to design a study, we'd probably want the same. I think finding that's going to be really hard. Finding dudes who are 10% body fat and an FMI of 18, that might be hard to find them. So that would be the ideal cross-sectionally.
Oh, isn't that's like your traditional millennial hipster, right? They're everywhere.
Yeah, we could just put.
They're either FMI of 18 and 10% body fat, or they're, have a BMI of 30 and pre-diabetes.
Yeah, that's like the Americano guy versus like the 3-shot sugar latte guy at the hipster coffee shop. Yeah, so exactly. we just got to put the flyer at the hipster coffee shop, and the recruitment flyer put it at the hipster coffee shop, and then we'll put it at the gym.
Do you know what? Like, I remember a couple of years ago, I went out onto the high street to try and buy some pants, American pants, not British pants. So like jeans, and like literally not even extra large or whatever, like waist 34-inch. I couldn't even get my feet into them, right? So there must be enough of these guys in that arena for them to exist as a study population, because they certainly don't make pants for people like me or you on the high street.
So this is I think our challenge for the next year is I'm down to throw money at this. It's not going to be that expensive, but this is kind of the first step in kind of turning. I don't think we're ever going to be able to turn this research around, but like look at more of an anti-fragility model and compare these. Let's just call it what it is. Let's compare emo hipsters to, jacked bodybuilders, and look at their ability to deal with 200 grams of gummy bears. Like that's what I want. Just the title of the paper: Gummy Bear Clearance by Emo Hipsters versus
bodybuilders.
Yes, versus thunderjacked individuals. So I think from a study design standpoint, that's where you'd start. And then probably not that sexy of a study design for us would be to look at that same person. The next step in the study design would be looking at what happens when you add 10 to 15 kilos of muscle mass to the emo hipster. And so that would be the follow-up study to our cross-sectional study. You probably missed me right there.
Yeah.
So I said the follow-up study to our, so we're really thinking in the future here at Bro Research Radio. So we want to be inclusive, not exclusive. So we want to be more like my wife, less like us. And so our first study is we're going to have the us versus them. So we're going to test the emo hipsters versus the jack bodybuilders. we cross-sectionally, and then of course, because we know which one of those groups is better, we're gonna then
Said
take
the guy aiming for inclusivity.
no. So this is how we're gonna be more inclusive. Well, then we're gonna obviously got to progress to a longitudinal study design. So our next study is to get the emo hipsters more jacked, and then see that's the study design. And you already have the recruitment population. So then we just forget about the jacked, the thunder jacked individuals. We're like, you already got it. You're good. Go about your peanut butter pie. And then we show the emo hipsters that they cannot dispose of 200 grams of gummy bears very well. And then they ask us, how can we dispose of 200 grams of gummy bears more better so that we're not as sad? and then we subsequently help them gain muscle mass. And then they subsequently can't go shopping at these streets in Seattle that I've never been to. But it sounds nice.
Well, if you're going to Portland soon, right? If you try and go clothes shopping, you'll probably struggle.
I'm not going to Portland.
Oh, you're not? You're staying at home?
No, I'm not staying at home either. I'm going to the Midwest. So it's always a little bit hard for me to go to the Midwest. Like I fly in and I'm just like, because in Costa Rica, I'm not. I mean, no one's. I mean, there are some aggressively big people still. They exist for sure, but not. I get lulled to sleep because there's a lot of work here, a lot of manual labor, and so people are still pretty healthy. But I go back to Wisconsin. It's pretty. I'm like, wow, this is it. Like this is 99% of people are in dire straits. And so there's a lot of, and that's why I go back and I kind of understand. Okay, like this is why the literature is the way it is.
Like that's the population that you're working with, right?
Unfortunately, and they're getting older. Like it's really. You think about the not to be too pessimistic, and I know you're there too, but like there's more people on this planet that are over the age of 65 than are under now. And so you combine age with the loss of muscle mass, with sedentary activity, man, it's just scary. The ability to dispose of gummy bears, not good, especially if you're a 5'4" Korean lady. A lot of people may not know this, but unlike myself, you are a fancy doctor and you work at a fancy place and you do fancy things. And so I've been wanting to ask you this question for a while. Is we have this textbook Pathogenesis of type 2 diabetes, and I know this is something that you feel strongly about, and I'm really, really excited to kind of hear you dive into it. But we have this, first thing that happens is you get this inability to deal with large amounts of glucose, or you get metabolically inflexible in that direction. Second thing that happens is now all of a sudden you need more insulin, so your beta cells start secreting more insulin, and then they blow out, and then you get NAFLD and kind of you get this downstream effects. And then also you get now even the textbooks are talking about this with alpha cell insulin resistance. Now you're going to get excessive glucagon secretion. And so do you want to just play that out for us, like that pathogenesis? Like how does someone really get type 2 diabetic?
Yeah, definitely. I think there are probably three main players in this, and the three being, I mean, you should probably include four. So the liver. So it's the gut, the liver, the muscle tissue, and the fat tissue. And there's probably an intersection between all four of those. And where things start to go wrong might be different from person to person. Certainly, there's been a lot of talk about loss of skeletal muscle tissue, insulin sensitivity, and that being, where things start to fall apart. And I don't think that's like the main crux of things, but it's certainly very important. We've talked about that already. The amount of muscle tissue that you have and remaining active, has a huge amount to do with how much glucose you can dispose of, your systemic insulin sensitivity. A key player seems to be how sensitive your fat tissue is to insulin. Like how much fat, if you measure it either in a human or in animals, how much glucose can your adipose tissue take up? So your adipose tissue insulin sensitivity If you sort of knock that out, say in a mouse, like you become almost instantly diabetic. So the insulin sensitivity of your adipose tissue is crucial, and that is determined by a number of factors. So kind of there's still debate on how, you know, how much this is the main issue, but you have some people talk about what we call a personal fat threshold. How much fat tissue can you accumulate before your fat tissue becomes insulin resistant and starts to say, no more, I can't take any more fat, I can't take any more energy, like I'm at maximum storage capacity. And that's partly determined genetically. So Caucasians seem to be able to accumulate the most fat mass before they become systemically insulin resistant. And then other, so if you think about Indians, some Southeast Asian populations, they get type 2 diabetes at a much lower BMI, or, you know, you know, they can be less fat before they become systemically insulin resistant. And then when you're in that state, then your fat, which is your buffer essentially for excess caloric intake, you know, that's no longer available to you, and then you essentially start to shove stuff wherever you can, and then it ends up in the muscle tissue, ends up in the liver, ends up in the pancreas. That's where you start to see problems with beta cell burnout. And during this whole process, you're starting to secrete more and more insulin to try and basically shove substrate wherever you can. And insulin resistance in the tissues also results in insulin resistance, you know, in the pancreas. So then that's where you have large amounts of glucagon, which is then telling your liver to make loads of glucose, even though you don't need it. And your insulin resistant fat tissue, because the insulin is no longer insulin sensitive, insulin isn't holding the fat in. It's, you know, it's there for substrate partitioning. And so then you have, in insulin resistant adipose tissue, you have higher turnover of fat. So basically free fatty acids and glycerol are sort of spilling out of your adipose tissue, particularly the visceral fat. That's going to the liver. The liver has upregulated gluconeogenesis inappropriately because it's also insulin resistant and is exposed to a lot of glucagon. So you start to make a load of glucose in the liver inappropriately because this can almost have a feed forward effect. And you can obviously overcome some of it by injecting exogenous insulin, you know, but you're just going to keep getting, you know, fatter and fatter, even though the body doesn't want to. The one key sort of player in this then is the gut. And we mentioned briefly the incretins and things like GLP-1 increase endogenous insulin secretion, which helps to maintain glycemic control. And you lose proper incretin production in the setting of metabolic disease. And an interesting thing is that the fastest way to reverse type 2 diabetes is to give somebody a gastric bypass, which is basically where you rearrange the stomach and surgically, and those people basically reverse their loss of normal incretin function almost overnight, and they're so that tells you that incretins and gut function are, you know, directly tied into metabolic health. When you then try and think of other ways, right? You know, if you are insulin resistant, you don't necessarily want to have a gastric bypass. So lowering carbohydrate intake can certainly help. If you're insulin resistant, you are carbohydrate intolerant, so that can certainly control the symptoms. And in some people can result in full reversal of the disease if it results in a long-term caloric deficit, which is at that point what you need. You need to remove the substrate from your stores so that you have that buffer back. And Roy Taylor he's in the UK, has done some studies with liquid hypocaloric diets in people with type 2 diabetes. And if they manage to get rid of ectopic fat and recover pancreatic function, which happens in a proportion of people in the responders, they also go into remission of type 2 diabetes. The next step, though, is looking at other things that might be causing the problem, you know, outside of just a pure caloric excess. And we know that systemic inflammation, infection, that certainly results in insulin resistance. There are, you know, other toxic exposures which might result in insulin resistance. Chronic stress is another one. So this is where the functional medicine paradigm can become useful, because, you know, if you just put somebody into a caloric deficit, or you restrict their carbohydrate intake and they don't see dramatic improvements in metabolic health, or, you know, you try and help them gain some muscle mass and that doesn't seem to be doing the trick, then there's you know, using a functional integrative medicine approach to figure out other things that might be affecting insulin sensitivity is really important. And I think that's the one thing that's kind of missing. You know, even though we're starting to see low carbohydrate diets and maybe hypocaloric diets in mainstream medicine to try and reverse type 2 diabetes, very few people are actually successfully increasing muscle mass on a population scale. And then there's always going to be you know, people, you know, you're missing other things that are going on, such as, you know, systemic inflammation that might be affecting insulin sensitivity. So it's just worth remembering that just because reducing carbs can you know, make you look less diabetic, it doesn't mean you actually solve the original problem.
Yeah, kind of just treating symptoms with food. Interesting too. When you said that, I immediately thought, okay, well, yeah, you also have if you have, you know, chronic inflammation going on, your ability to put on muscle is going to be blunted as well. So you're going to be hurt. So you're hurting from all angles, and so that's kind of the play, is if there is some kind of, you know, smoldering inflammatory response, none of these, like what we're talking, this is like, it's always good. A lot of us kind of get entrenched, and that's kind of the problem with, you know, the fancy academia. I think it's getting better. I'm not a pessimist by any means. And I think that, like, people are getting more interdisciplinary. And I definitely saw that when I was in academia. And so the problem is we get entrenched in our viewpoint, and then we don't get out of it. And so if you think hypocaloric is the thing, and then you just miss muscle. And then if you think, if you're like me and everything's muscle, then you're super muscle centric, and you didn't put your head out of your trench and like, oh man, this could be a chronic inflammatory issue and has nothing and that's blunting my ability to put on muscle, and that's blunting my ability to lose fat, and that's why I'm insulin resistant, or that's part of the reason. So that's super interesting. And so you're gonna be down here in March jamming on, I think you're day 2, you're talking for you're presenting for 90 minutes, and you're gonna present, kind of go into a lot deeper. You're going to present on this model, and then day 3 you're presenting again. And I had the pleasure of reviewing one of your. Is that Impress yet or no?
No. So I just submitted it, and then I put a preprint up so that it was just online so people could read it. But yeah, I'm working on getting it published currently.
And so day 3, you're going to talk about what you've been kind of working on the phenotypic and / genetic side. Yeah. And what that'll be.
You want me to talk about that?
I mean, it's super, like, I read the paper, and I haven't bought into, like, I don't want to call it, like, I'm not going to throw out any names out. But there's a lot of acronyms in the functional medicine world that are very, like, predeterministic based on your genetic profiles. Yeah. And I've always like been super squeamish about anybody trying to tell me a super simple story with, like, things that just look sciencey enough. Yeah. And I think that's what you did a really good job of, like, because you get a lot of scare tactics. Like, I'm like, people come to me, like, so scared. Yeah. And it's not warranted.
No, this is the thing, and I kind of, until I really dug into it, and again, it requires, you know, if you apply just basic statistical theory, and like when we're there, I'm talking about this, I'll sort of lay that out. But if you have any idea of how statistic works, and then you look at the papers that people are using so the kind of, you know, the kind of thing you hear is that, like, if your MTHFR isn't working properly, right? Like that's the most common thing. So basically, based on a genetic test, somebody is telling you that some enzyme, like, just to begin with, that doesn't make any sense. But then when you start to look at the actual data on this stuff, it's super variable from person to person. Like, what you know, their enzyme function is, whether that actually translates into a change in phenotype, right? And that's what we care about. We care about the phenotype, like the actual physical things you can measure on the person, like their blood glucose level or their homocysteine level, or, you know, how tall they are or how fat they are or how diabetic they are, their blood, you know, and all of those things you can measure. And if you then look at how tightly genetics, you know, the most common genes that you might measure on like 23andMe, if you look at how those actually relate to final phenotype, it's so variable and the effect is so small that you may as well just not even bother thinking about it. But you know, there's a whole sort of like step-by-step process that I kind of put together just based on basic statistical theory, and you can kind of just see, you can make these nice graphs, you can look at it and think, you know, how much is this actually likely to affect me? How much should I worry about this? And for many, many things, like the things that are best understood and the genes that have been most widely studied, most of them, the environment dominates. Like the effect of genetics is so small that, again, it's probably not even worth worrying about.
Yeah, I think I can't remember who posted this study, but it was like the idea of like genetics predetermining your ability to lose weight, and it was like genetics made up like 2 to 3% of your ability to lose weight. And so I anytime someone tries to sell me on genetics being the thing, I get real squeamish, and this may not sound like a big issue to a lot of people, but I mean, we're talking potentially about like this has got to be like $1 billion industry right now of like selling people things based on, you know, their ACT1 gene, and they're, you know, you're never gonna make the Olympics because you might as well just stop training because you're never gonna be an Olympic sprinter in this cross-sectional study. And so it's really
I actually looked at, so I had, you know, so I do some work with some Formula One drivers, and this came up with one of the coaches. There's a question about this, so I applied the same. So it's not in the paper, but I applied the same, you know, process to ACTN3, right, which is supposed to predict, you know, power and response to training, and the data is so variable. The error bars are so huge in the papers that are looking at this that like they didn't even use the right statistics to measure the difference between groups, right? So then even to start with, you don't even know if there's an effect there because the phenotype and the response to training is so variable from person to person. Like even people who are saying, oh, this paper says that there's a difference here, that paper doesn't even say that because they don't understand their data properly. So anytime this stuff comes up, you have to go back to the paper. You have to actually look at what data's there, how like you are the people they're studying. Did they actually even do the study correctly? And in a lot of cases, they just didn't. So yeah, it's super interesting. And I can't find a single gene where I'm like really concerned that it has a dominant effect on phenotype.
Yes, and you're not talking about like one gene diseases, like, you know, like PKU. You're talking about these like MTHFR, MTR, all these methylation genes that everybody gets worried about.
Yeah.
And then we also emailed, I think, another one that's pretty like, I get worried because I think that this is ironic, right? That even that statement. My biggest beef with Funk Med is the selling of the selling of stuff that's just sciencey enough, and that's just, to me, unethical. And it rubs me the wrong way. And then the other thing that gets me is like this air of omission, or just not being aware that this is not a thing, right? And then you scare people. And so that's what seems to be happening with a lot of these genes, definitely methylation, but the big one that people that in the current medical model, there's kind of this debate of if they should even tell people, and that's ApoE3 and ApoE3 and 4.
Yeah, and that's and we did talk about this on email, and that's probably, like I just said, that there's no gene that I'd really be concerned about, and that's one that maybe starts to sneak into significance. But the if you look at the different studies, so ApoE4 is the one you're worried about, particularly in terms of Alzheimer's disease. risk, and there isn't increased.
These are like, we're talking like if you're an ApoE44 like 11 times, and some of them have found like 20x.
Yeah. So up to 20x, and the thing that I always come back to, and this question hasn't been answered perfectly, but the thing I always come back to is what's the gene environment interaction, and when you have so ApoE4 seems to accelerate the neuronal response to injury and neurodegeneration in the face of injury. But we know that the modern environment continuously provides neurological insults, be they from chronic stressors, hyperglycemia being one of them, loss of proper hormonal function, which acts as a neurotrophic factors. Systemic insulin resistance, also a big one, because you're not having the right, insulin acts as a trophic factor in the central nervous system. When in that kind of setting, in the setting of the modern Western diet, those inputs which cause like continuous neurological insults, then ApoE4 certainly seems to accelerate the risk of dementia. But in hunter-gatherer populations, it doesn't. So yes, it seems to be a real risk factor if somebody is living true to the current modern environment. But if you're somebody who's managed to engineer something that looks more like an ancestral environment, and that can just mean that you move, you retain some muscle mass, you eat something resembling a real food diet, you have some kind of stress management process, you expose yourself to light when it's light outside and dark when it's dark outside, that kind of stuff, you have some social connection. In that setting, it may be that ApoE4 doesn't really matter that much anymore. And again, I am conjecturing on this point, but it's just worth remembering that the population that these SNPs are being studied in is the population where 99% of people have suboptimal metabolic health and or are overweight and or have a chronic disease and or are on one or more medications, right? That's the average American adult. So that's the setting in which these risks are being tested. So I have a feeling that most of that excess risk disappears if you control those factors, but that requires hard work on the part of the individual. So again, like that is maybe a reason for those people to be more stringent in their lifestyle modification, if they're willing and interested to do that. The one thing that, again, I mentioned when we were emailing back and forth, the one thing, if I was an ApoE4 carrier, either heterozygote or homozygote, I would not do fight sports or play football.
Yeah, don't get hit in the head. Don't
get hit in the head, because that is, has a reasonable amount of human evidence for it, that when they've looked at CTE, the chronic traumatic encephalopathy, the people who are ApoE4 carriers seem to require fewer hits to the head, fewer concussions, but end up having worse pathology. So yeah, that's but that just, it's the same as everything else, right? If you protect your brain from both a lifestyle, and other health standpoint, then how much excess risk does ApoE4 give you? Maybe not that much.
And the hard part is we're never going to see those research trials, because those are so hard to run. We're talking about longitudinal mortality data.
Yeah.
And then you have, which is observational in nature, but you would essentially have like this case control model where you would have, these people with the Western diet and ApoE44 died this. It wouldn't be that complex of a study to run, but it's just so long and going to take so much. I guess it wouldn't even take that much money. You just have to follow a large amount of people. And then you also have, in that study, you're going to have, that's kind of a cool study, because you wouldn't even be worried about the healthy user bias, because you'd almost be taking this convenience sample of all these people that do these things versus and so then you kind of have this heterogeneity of samples, and then you would just see, what's the prevalence of Alzheimer's. The problem is that 1% of the population is just so hard to find.
Yeah, there's just fewer and fewer of them nowadays. And in reality, the people who, and this is kind of where the diet wars are taking off at the moment, is, people talking about whether a carnivore-based diet or a plant-based diet is better for, personal health and all this kind of stuff. And in reality, the kind of person who wants to know that answer, they haven't existed until now. The kind of person who is conscious about their stress and their sleep and their movement and their diet in a way that's sort of evidence-based and well constructed in the modern environment. Just those people haven't really existed to be tested until the last few years. So sadly, you kind of have to do the best with what you've got, and just that population is so small at the moment.
And be super, like, I've found those people are very they're very flippant, and they're very easily manipulated in terms of, like, like someone can sell them this genetic test that says, okay, you do best on a plant-based diet, or you're going to do best with high intensity interval training. I'm like, dude, there's no way that your genetic can tell you that.
Nope.
Zero way. But they seem, those type of people, like you might quote unquote, like, label them as biohackers. They tend to move around a lot, and then they just tend to be very, very just set in their ways once they get something that works for them. And that's tough to deal with. But if you are, I think if this ApoE44 thing, if you have that, if you are an ApoE34 and an ApoE44, you really do want to take this. I think because Alzheimer's is 100% the scariest thing for me. Like, give me a heart attack. We've talked about that. Like, just give me a heart attack when I'm 80 and let me just go fast.
Yeah.
Whereas Alzheimer's, you're talking, a decade of people having to take care of you. And it's just a slow decline. And so that's, if you do have that risk factor. And so what I see a lot is you see it in families, right? So they know they have an ApoE44, and then one of their parents got Alzheimer's.
Yeah.
And their parents lived, they lived through that Industrial Revolution. They lived that Western lifestyle. And so you can potentially spin that around. We don't know, but that's the play regardless. Like, you got to do it.
Yeah. I think, if you're playing the odds, and particularly knowing that the width of the risk for something like being an ApoE44 is from like maybe 3 to 4x up to 20x, depending on the study. But that also tells you that you have a huge amount to play with, right, in terms of how much extra risk you really do have. And all of that's going to come down to lifestyle and the environment. And the things that we know are required for human health are all the things that we've mentioned already. So you have a huge amount of potential leeway and ability to dramatically reduce your risk, but it's all going to come back to those same basic lifestyle factors.
So everyone, I have really, really, really good news that you're going to be excited about. I took my glucose again while Tommy was on his diatribe, and it's at 87. So we're back.
Boom! Look at that.
2 hours after 140 grams of carbohydrates, 87.
Perfect.
Yeah. Bam. So Tommy's coming down in March. If you guys just didn't realize from that banter, there's not a lot of things I get pretty excited about stuff. That's not true. But one of the things that gets me really, really excited is having contextual scientific thoughts and having a lot of people in the room that have different viewpoints and different histories and different specialties, because that's when cool things start to happen. It's like, oh, I never thought of it that way. And then that goes down the rabbit hole. And that's my goal with these March retreats, is to kind of create more of a lab type environment. And that's, Tommy's going to be there for all of week 1 for Funk Med and Nutrition Week. And then the attendees are going to be presenting. And then our goal is to have these types of scientific talks throughout the week. And so I'm super excited about it. And I'm really honored that you're coming and that you're going to be there. And just honored that you're a piece of this Bro Research puzzle, man. So thank you for all that you do. Thank you for taking the time to come on and chat with me on what day is it? Random Thursday. I don't know what day it is anymore with the baby. It's wild. But thank you, man. I really appreciate it. Anything that you want to say, anywhere you want to point and direct people to get a hold of you?
Well, first to say, it's a huge pleasure as always, and I'm super excited to come back to the jungle and hang out with like-minded and differently minded people, like you said. And that's definitely the fastest way to learn. And I know that you're encouraging people to you know, regardless of their background, you know, make the jump and do some research and present it in a friendly environment so that everybody learns. And yeah, I'm really excited to be a part of that. But other than that, I didn't, my wife did. My wife Elizabeth recently remade my website, drragnar.com. You can head over there. It's mostly going to be the podcast that I've been on recently, so this one will go up there, and some other ones that I've been on. And then at Dr. Tommy Wood on Instagram, occasionally get some love, so you might see me there. It's either there's some science, there's me lifting stuff, and then there's pictures of my dogs. So who wouldn't want that combination, really? Yeah.
Strong. Wow, you're almost at 1,000 followers. I'm putting in that work. Last question, I refer you clients that I know fit into your wheelhouse. Are you currently taking on one-on-one clients?
Yeah, occasionally. It's usually at the moment I don't have a good setup for ordering lab tests because I'm just kind of doing some freelance coaching because I'm basically a full-time academic nowadays. But if people have some test results or a background of whatever that they would like to just discuss with me, and I'm very much let's have a look, let's have a go. You know, by the time people come to me, it's usually super complex, and you just end up sort of figuring stuff out as you go. So I will never pretend to have all the answers, but if people are in that kind of scenario and they just want another mind to bounce ideas off of, then yeah, I am doing some one-on-one coaching. So
you heard it, guys. If you have your 23andMe raw data, Tommy Wood is your guy. Just go to him, send him your genetic gene outputs, and he will tell you exactly what you need to do.
Yeah, just drag it to that little trash icon in the middle of the and go for a walk.
All right, man. Hey, I appreciate you. And it's close. We're like I'll see you in like 4 to 5 months.
Yeah, I'm excited.